Hello, my Science Olympiad Astronomy students asked me about question 16, so let's look at it. We're going to go ahead and put it online because we're probably going to forget how to do it in about a couple days. A galaxy containing a Type 1a supernova with a peak apparent magnitude of 16.5. The galaxy is 3 arc-minutes in diameter. What is the galaxy's diameter in parsecs? Give one significant figure. So let's go ahead and draw out what we've got here in our problem. And I'm going to go here, and here you can see me sitting on Earth with my telescope, and I measure that the apparent magnitude with my telescope is 16.5. And then I go ahead and measure the angular diameter of this galaxy. And again, we've got a Type 1a supernova in the center, or in the galaxy, that we know that its apparent magnitude is 16.5. So we're given the apparent magnitude, and we're also given this angular diameter, which we're going to call theta, is equal to 3 arc-minutes. And then they're asking for the diameter in parsecs, so the distance of this galaxy that has this Type 1a supernova that exploded, that it caused this apparent magnitude of 16.5. So as with any science problem, we probably need an equation, and we will use the small angular formula, which says that the tangent of theta is equal to the opposite, which is the d, over the adjacent, which we're going to call big D, and that's the distance from the Earth to this galaxy. And because this distance is so much greater than this distance right here, we can basically say that theta in radians is going to be equal to d, little d over big D. So now I'm going to solve for little d and times both sides by d, and I'm going to get d equals theta times d, which we'll calculate in parsecs. And in order to calculate d, I'm going to use the distance modulus equation, which says that 10 raised to the apparent magnitude minus the absolute magnitude plus 5 is divided by 5 is the distance. So I can go ahead and solve for this because I know that the apparent magnitude is 16.5, and I guess you need to know that the absolute magnitude is minus 19.3, and I'm going to add 5 to that, then divide by 5. And then I will go to my handy-dandy calculator. And, sorry, I have to put my parentheses. There we go. 16.5 plus. It's a minus 19.3, so that's a plus. So minus and minus is a plus. So 19.3 plus 5. And that's all going to be divided by 5. And that gives me this 1.4 times 10 to the 8th parsecs. So D is equal to 1.4 times 10 to the 8th parsecs. And I now have my D. So now I need my theta, which right here is theta. I want it in radians, and I've got it in arc-minutes, so I have to use dimensional analysis and say that 3 arc-minutes for every 60 arc-minutes, there's 1 degree, and for every 57.3 degrees, there is 1 radian. So I will go back to my calculator, and I will type in 3 arc-minute, we're going to divide that by 60, and then we're going to divide that by 57.3, and that's going to give me 8.7 times 10 to the minus 4th. So that's 8.7 times 10 to the minus 4th radians, which is the dimensionless unit. So I'm going to go ahead and plug that in here. So I will go back to my calculator and basically multiply 8.7 times 10 to the minus 4th. So I'll go ahead and get my answer, and then times that by that 1.4. We'll go up and grab it here. 1.4 times 10 to the 8th, and I'm going to get 1.2 times 10 to the 5th. 1, 2, 3, 4, 1, 2, 3, 4, 5. So D is going to equal 1.2 times 10 to the 5th parsecs. And it said to round to this one significant figure, so 1.2 rounds to 1 times 10 to the 5th parsecs. I go back to my question, and you can see that that's the answer right here. So thank you for listening, and have a great day.